Good evening to one and all. Today I am going to present a topic about asymptotic notations. What is asymptotic notations? The main idea of asymptotic analysis is to have a measure of efficiency of algorithms that don't depend on a machine specific constant and don't require algorithms to be implemented and time taken by the programmers to implement to be compared. Asymptotic notations are a mathematical tools to represent the time complexity of the algorithms for asymptotic analysis. Next, asymptotic notations are mathematical tools to use analyze performance of the algorithms by understanding how well their efficiency changes as per the input sizes grows. For example, upper bound and lower bound and maximum bound and minimum bound. These notations provide access and consist way to provide the behavior of an algorithm's time, space and the complexity of the program. Next, it enables the comparisons of algorithm efficiency by abstracting away the machine specific constants. Asymptotic analysis allows for a comparison of algorithm space, time and complexity of the program size, and it will grow depends upon the worst case, best case and average cases. By using asymptotic notations such as big omega, theta and big O notations, then we can categorize algorithm based upon their worst case, best case and average case and time or space complexity, providing valuable insights to their efficiency. Next, there are three main asymptotic notations we are following in following functions. First one is big O notation, omega notation, and third one is theta notation. First we are going to see a theta notation. Theta notation encloses the functions above and below. It's since it represents the upper and lower bound of the running time of the algorithm, it is used to analyze the average case of the complexity of the program. This is theta notation. Theta, you are the adding running times for the each possible input combination and take the average cases in the theta notation. Next, here we are using graph notation. The execution time serves as both lower and upper bound of the algorithmic complexity. Next, big O notation. Big O notation, it fully depends upon a worst case, that is upper bound of the running time of the algorithm. Therefore it gives the worst case complexity of an algorithm. It is the most widely used notation in asymptotic notations. It specifies the upper bound of functions. Next, the maximum time required by an algorithm or a worst case complexity. It runs the highest possible output value of big O for a given output. Next, big O, that is worst case. It defined as the conditions that allow an algorithm to complete statement execution in the almost amount of a time possible. Next, we are using graphical notations. For big omega notations, it returns the highest value or possible value output value big O for a given input. The execution time serves as an upper bound algorithm time complexity for big O notations. The worst case complexity of insertion sort is omega or big O n square. The best time complexity of insertion sort is O of n. The big O notation is useful when we are using an upper bound on the complexity of an algorithm. Many times we easily use to find the upper bound by simply using this big O notations. Next, final one is omega notation. Omega notation is used to find the best case of an algorithm. The execution time serves as a lower bound of an algorithm and time complexity. It is defined as the conditions that allow an algorithm to complete statement execution in the shortest amount of time. That is omega notation. Here we are using Cg of n greater than or equal to f of n. This is the statement for omega notations. Next, here we are using graphical representation by using f of n and g of n for omega notations. Next, final one is properties of asymptotic notation. Here we are using five different types of properties. First one is general property, second one is transitive property, third one is reflexive property, third one is symmetric property, fifth one is transpose symmetric properties. General properties, we are always using f of n and y of n. Simply we are adding two things. This is general property where a is the constant in first property. Next one is transitive property. Here f of n and y of n equal to, again we are gaining o of h of n. This is a transitive property. Next one, third one is reflexive property. Here we are using maximum value of g of n and x of n. It is a reflexive property. Next, fourth one is symmetric property. Here we are using both f of n and g of n is more than equal. This is symmetric properties. Next, transpose symmetric properties. This is the final property of asymptotic notations. Transpose symmetric properties, f of n is o of g of n, then g of n is omega f of n. This is the final property of asymptotic notation. Thank you for giving this opportunity. Thank you.